All right, welcome everyone. Thanks for joining the webinar. We're going to go ahead and get started. My name is Alex. I'm your moderator for today. Presenting today is our Senior Application and Process Engineer, Ty Sjomeling. With over 7 years of industry experience, Ty has worked at Joby Aviation, where he focused on certifying flight-critical components manufactured using laser powder bed fusion. In today's webinar, we'll begin with an overview of Farsoon technology and our extensive product offerings. Then we'll dive deep into our FS350M system, exploring its hardware and software features, as well as our support reduction system. Finally, we'll showcase some real-world applications. This webinar is being recorded. If you have any questions during the webinar, please drop them in the Q&A session, and we'll have dedicated time to answer them at the end of the presentation. Now, with that said, let's dive in and enjoy the presentation. Ty, please take it away.
Thanks, Alex. Hey, everybody. As Alex mentioned, I'm Ty Sjomeling, Senior Applications and Process Engineer here at Farsoon Americas. I'd like to start off by thanking everyone for taking time out of their day to join this webinar. As Alex mentioned, if you have any questions throughout the slides, feel free to post in the Q&A section, and we'll be happy to review those questions at the end of the presentation. If you happen to be watching a recording of this webinar at a later date, you can send an email to us at contact@farsoonam.com. That's CONTACT@FARSOONAM.com. And I will switch to the next slide as soon as it loads. There we go. So we'll start things off with a little bit of background on the company. So Farsoon Technologies was formed in 2009 by its founder, Dr. Xu. The company started in a small warehouse in the outskirts of Changsha City, located in Hunan, China. There, 10 employees began working to build a company with the motto "Open for Industry." So since that point, Farsoon has proven itself as a global innovator, expanding into more than 30 countries and growing its team to more than 700 employees. Of those 700 employees, over 30% are dedicated to research and development efforts to stay on the cutting edge of technology. Today, Farsoon Technologies headquarters remains located in Changsha, China, but has offices spread across the globe, including Farsoon Europe in Germany and Farsoon Americas, located in Austin, Texas. In more recent years, Farsoon has continued its exponential growth, expanding its headquarters to a new, larger campus and reaching a milestone of selling over 1,000 machines globally. So on this slide, you can see in the top left corner, we have a rendering of our newer campus located in Changsha, China. That rendering is a little bit old because we're actually moving into that facility as we speak. In the bottom left corner, you can see our new materials factory. I'll talk about some of our materials offerings in a minute, but we're greatly expanding those offerings to allow production of material powder for many other applications. And then in the right side, you can see a photo from our 1,000th system sold celebration. And if you look closely at that picture, you'll notice our 1521M in the background. As Farsoon Technologies expanded into North and South America, the need for local support and inventory grew. As a result, Farsoon Americas was formed in 2017, bringing local service and expertise to the area. Farsoon Americas has since grown its on-hand inventory to include critical spares, consumables, and materials to shorten lead time to customers. Along with key inventory, the team has a dedicated service team with years of industry experience and an application team ready to take your material development questions or lend a hand with customizable on-site training for customers new to laser powder bed fusion technology. On this slide, you can see a breakdown of our US team members on the left, and then some photos of our Texas facility on the right. You can see we currently have 3 polymer machines in the warehouse as well as a good amount of our ready to grab inventory. We also have a second warehouse location for more of our large material storage and cold storage. So although Farsoon is most well known for our machines, we do offer an entire manufacturing solution for customers, including machines, materials, software, and application support. For hardware, Farsoon offers both polymers and metal machines ranging in size from 1 to 653 liters in build volume. For materials, we offer internally manufactured PA12 and PA6, as well as a long list of third-party material partnerships. These partnerships allow customers to choose their own path on material selection while still having Farsoon's backing on parameters and mechanical data. For customers looking to manufacture parts with materials not currently in Farsoon's lineup, our fully open system allows customers to optimize parameters to fit their needs. For software, we offer build preparation, machine operation, in-process monitoring, and log review software, all of which utilize Farsoon's open platform architecture. Lastly, in applications, we offer process engineering, testing, qualification studies, and internal benchmark production for customers looking to make the switch to Farsoon. Rolling into our machine portfolio, you'll notice we have 8 base model configurations ranging from 1 to 653 liters in build volume. On the bottom left, we have our smallest metals platform, the FS121M. The 121 is popular among universities interested in giving students hands-on experience, as well as companies looking for a low-cost material development platform. Next in the lineup, we have the FS273, available in both single and dual laser configurations. The 273 is another favorite among universities and job shops looking to do both material testing and batch production for small components. For customers looking for a slightly larger build area at a reasonable price point, the FS200 comes configured with dual 500-watt fiber lasers and is the smallest machine in Farsoon's lineup to include dual direction top-down recoating system, which, as many of you know, greatly reduces setup time and time between layering. After the 200, we return to the bottom feed systems with the FS301M. The 301 can be configured with either 1 or 2 lasers. However, either configuration allows for full coverage of the entire platform by each laser, meaning that you can build a single part anywhere on the platform and assign it to just one single laser. Next, we get to the topic of today's webinar, the FS350M. As you can see from above, the 350 comes in at one of our medium volume machines and boasts some of the most up-to-date technologies, which I'll discuss in the next few slides. After the 350, we start to move into our larger continuous production platforms, such as the 422. The 422 features our CAMS, removable build cartridge system, allowing the customers to move depowdering of parts to ancillary equipment and limit downtime between print flips. Next in the lineup, we have our 722M. Now you may notice the 722's 8 laser configuration in the slide, but I also like to highlight the fact that the 8 laser configuration can be paired with not only our 500-watt lasers, which you see on all of our other platforms, but the 722 can also be purchased with 8 1,000-watt laser systems. Now, that becomes important if you're looking to increase your scan speed or drastically increase your spot size at the powder bed, where that 1,000 watt, can really be utilized. Lastly, we have our 621M. Now, I have to say from the slides here, this picture really doesn't do this machine justice, just because of the sheer scale of it. At 620 by 620 millimeters build area and a configurable Z height of up to 1.7 meters, this machine is currently the largest machine we have available in the US. Now, for the remainder of the webinar, I'm going to be jumping back and focusing on the 350. But if you have any questions about these machines or further questions about our polymer machines, feel free to reach out via email, and we'll be happy to put you in contact with the proper sources. So now that we've discussed hardware, let's take a look at some of Farsoon's software offerings. So if you've ever prepared builds using our software before, you're most likely already familiar with BuildStar. BuildStar is our in-house developed build preparation software, allowing customers to do geometry preparations, model support structures, select scan strategy, and modify build and parts parameters for the build. If your company is already integrated with another software platform, you can easily import your prepared files using our third-party software extensions. Once you have prepared your build packet using BuildStar, you can move to the machine operations software, MakeStar. MakeStar allows the user to prepare the machine, manually move machine components, and kick off builds. Once the build is running, MakeStar can be used to monitor build progress and even modify parameters on the fly. For monitoring of the printing process, the FS350M comes with Farsoon's real-time monitoring and compensation software. This software can be used to monitor the recoating and build process, as well as recording video and photos of the entire build. Those videos and photos can be used for traceability and troubleshooting if you do have a failure throughout the print. This intelligent process control system can be set to detect layer defects such as short feeds, layer flaws, part deflects, and more. Using this software, compensation can be used to correct situations such as short feeds without any user intervention needed. So on this slide, in the top right corner, you can see the F-theta lenses and the laser glass of the FS350. You also notice that our camera is centrally located between all of those lasers, giving our picture quality a very clear exposure and contrast composition. In the bottom, you can actually see some of our previous versions of machines where that slight off-angle attack from the camera gives us a little bit of a shadow and makes part deflection, compensation a little more difficult. So I think that's a great improvement with the quad laser camera system on the 350. Throughout the entire build, key build data, including chamber oxygen content, gas flow speed, plate temperature, and more, are all continuously logged and can be easily viewed through Farsoon's log viewing software. The software can quickly generate build graphs that can be used to check for irregularities during the building process. On the left there, you can see a snippet of our MakeStar software, and the FS Log View software is launched from inside the MakeStar software. And then on the right, you can see a quick example of our monitoring software in use. So on the left there, you can see build records from all of the past builds that have been run on this machine. And then on the right, you can select parameter-based objects to be graphed below, and you can graph those based on either time or by layer. So returning focus to the 350, let's begin by running through some of our technical specifications of the machine. The 350 comes standard with our real-time monitoring software, as I mentioned, the latest in Farsoon's gas flow hardware, and a robust dual-direction top-down recoating system. The machine offers a build area of 433 by 358 millimeters, and that area is covered by 4 overlapping 500-watt fiber lasers, each paired with a 2-axis galvo and F-theta lens configuration. For handling of powder, our top-down recoater system is fed by a hopper at the top right of the machine. This hopper is automatically refilled throughout the building process using our portable powder conveying unit. Our portable powder conveying unit, paired with our powder handling cartridge and sieve, make sure the powder never leaves an oxygen-controlled environment throughout the entire building and handling process. With this 4-laser configuration, Farsoon offers multiple advanced scanning strategies that can be used to optimize for productivity or quality of each part. Regardless of scanning strategy, customers can expect uniform material properties throughout the entire build. On your right, you can see a snippet of our technical data sheet on the 350, which highlights some critical dimensions, power requirements, and a few other things I've already covered in the previous slides. You can also see we have a few notable points on the safety and standardization of this machine. The 350 viewing window is OD5+ rated at our specific wavelength and complies with the EN standard screens for laser working places. All exhausted gas from the machine is filtered by an H13 filter element to confirm all powder particles are captured before they are exhausted into either the facility exhaust system or externally. The machine offers an external ambient oxygen monitor for alarming operators if the oxygen content in the room ever gets below 19%. The 350 utilizes some of Farsoon's latest advancements in gas flow technology, which has improved our machine's part quality consistency and reliability. On the 350, we utilize multi-layered airflow to reduce turbulence across the plate, and our optimized air outlet ensures complete removal of particles produced through the melting process. The particles that are removed from the build chamber are then processed through our 3-stage recirculating filter system. This RFS uses a cyclone separator, rough filter, and fine filter to prolong the time needed between filter changes. To also increase the duration between filter swaps, the 350 utilizes an automatic backflow function to clean the filters as differential pressure increases. This gives our rough filter a lifetime of about 1,500 hours, and our fine filters a lifetime of 2 to 3 years. Now, for customers looking for an even lower filter maintenance costs and simplified waste management system, the machine can also be purchased with a lifetime filter. That lifetime filter is designed to have a lifespan of over 100,000 hours. To minimize time between layers and maximize laser on time, the 350 is outfitted with a dual direction recoating system capable of traveling up to 400 millimeters per second. That 400 millimeters per second gives us an average time between scans of 8 seconds when utilizing dual direction recoating. This dual direction recoating system, paired with our top-down powder feed system, makes the machine a great fit for volume series production applications. Now, powder management for the 350 is broken into manual stages, allowing users to track powder use count, monitor powder characteristics between builds, and track sieve throughput. After the build process in the machine is completed, the parts are depowdered through the glove ports at the front of the machine and moved to the powder sieve via 50-liter powder supply tanks. The powder sieving unit then sieves the powder at a rate of more than 100 kilos per hour. From the sieve, the powder is transferred via those 50-liter powder supply tanks to the powder delivery unit. Now, the powder delivery unit can be filled with 70 liters of excess powder and can then sit next to the machine, automatically filling this powder supply tank as needed for the build process. With the machine's quad laser configuration, the user has the choice of scan strategy. Scan strategy can be optimized for laser balancing, spreading the load of part scanning among all available lasers to reduce layer time, or limiting the part to be scanned by the fewest number of lasers possible, improving surface quality in the stitching zones. From the video on this slide, you may notice when the scanning strategy is set to productivity mode, it not only optimizes for lasers per part, but it also optimizes the scan order to limit jumps and lower the build time by maximizing laser on time. Whereas when the machine is set to quality mode, the build is optimized for gas flow path. We can also optimize parts using our high productivity core scanning strategies. This strategy allows the part to be broken into cores where high-speed parameters can be used for selected hatching. This feature allows the user to have separate parameters for part contours, normal hatching parameters for hatching interfacing with contours, and high-speed parameters for hatching not interfacing with part surfaces. This feature, coupled with our variable layer height option, means we can optimize for surface quality and print speed in the same build. So in the top right of the slide, you can see we have our quality mode, normal mode, and productivity mode. And in the productivity mode, what I mean by limiting your jumps is the scan is moving pretty much from left to right for each laser designation. And so by doing that, it's limiting the time the laser is actually delaying between scans because it doesn't have to start each path over with a new jump trajectory. Whereas in the quality mode on the right, you can see every time it's laying down a new layer, it's making a small jump. And then normal mode is kind of a culmination of the two modes. So aside from the printers, Farsoon is also busy developing accessories that can improve both our post-processing of parts and the maintenance of our machines. A great example of this development is our Precision Cube. The Precision Cube was created to lower multi-laser machine calibration time and in turn, decrease machine downtime. Using the Precision Cube, we were able to get a maximum XY error of 50 microns and a laser-to-laser overlap accuracy of 30 microns. This advancement took a task that could take more than 10 hours down to a simple process that takes less than 3 hours. On the right, top right, you can see some screen grabs of our beam profile, which you can see has very good ellipticity. And you know, this beam here is a very tight focal beam. And then on the bottom right, you can actually see the output we get from our XY calibration using the Precision Cube. Another recent advancement is the development of our support reduction system, allowing parts to be printed with significantly fewer supports, in turn, lowering material consumption and increasing post-processing efficiency. For those of you already in the industry, I do not need to elaborate on why this system is useful. Fewer supports lead to less time removing supports, shorter EDM cuts, and even less build platform resurfacing, not to mention less powder consumption and fewer cavities to trap recyclable powder. Here, you can see an example of our support reduction system in use. With traditional support design, this part took 30 hours to print and 8 hours to remove supports, not counting the internal supports that were unable to be removed before sectioning of the part. After running the build through SRS, we were able to build the complete part in only 20 hours with no internal supports needed. This development not only allows for reduced production costs, but also allows for improved part quality and traditionally supported areas. It also enhances design freedom of parts that previously could not be printed with internal supports. Common applications for the FS350M include batch production of small components and custom quick turn tool molding. On the left, you can see with only a single build, Highlight Bikes was able to produce over 30 yokes to be used on their titanium bike frame. This build is a great example of optimizing builds for surface finish by utilizing the machine's 75 micron spot size and quality scan strategy. On the right, we have a common application for many of our medium machines, quick turn tooling. These molds were specifically run on the 350 due to a short lead time requirement by the customer. With the combination of the FS350M's quad laser configuration and variable layer thickness build strategy, molds will be able to be printed in less than 24 hours. Normally, in a traditional process, the lead time for these types of parts can take up to 2 weeks. All right, that brings me to the end of my slides for today. Again, I'd like to thank everyone for taking time out of their Tuesday to join us. And if you happen to be attending IMTS next week, stop by and say hi. If you have any questions about the slides that I ran into, I'd be happy to run through them a little more depthly now or cover those questions as we go. Again, if you have any questions watching this after the fact, feel free to reach out via email at contact@farsoonam.com. Thanks, everybody.
Awesome. Thank you for the very detailed and technical presentation, Ty. All right. So at this point, if you have any questions regarding any point of the presentation, please drop them in the Q&A. We already have a few questions trickling in. We'll go ahead and try to answer them. The first one, someone asking, how much slower is quality mode as compared to the productivity mode? And what part detail resolution is lost in productivity? I believe they're referring to the scan strategy.
Yeah, absolutely. So you are going to have a slight increase in build time when running via quality mode, just because you're going to be spending a little more time running with only a single laser as opposed to multiple lasers throughout the entire build. Depending on the geometry of the parts, this could increase the build by 10%. But if you're doing, say, a complete quarter of the build and all 3 other lasers are sitting idle throughout the entire building process, you could see a much higher increase in time difference.
Great, thanks, Ty. And we have another question. Question is, does support reduction system work in all modes, or does it have its own quality mode?
So the SRS can be used in all modes, and let me pull up the slide here. SRS can be used in all modes of scanning strategy, and it's actually kind of a culmination of modifying your part trajectories, scan trajectories, and delays between layers for additional cooling to lower thermal stresses throughout the printing process. And so regardless of your scan strategy, you can use SRS.
Great, again, thank you, Ty. And the next question is also regarding the SLS. Do you use separate software for SRS functions, or do you already have certain parameters set?
That is a great question. So at this time, what we're doing for SRS is we're running our customers are running their parts through the normal build start process, creating the slice packet and getting a rough estimate of what they're looking for in the final part. And then they're actually sending that to our team in Changsha, who's running SRS on a system they have locally there. And then once the system has run its simulations, it's being sent back out to the customers. Now, as we progress with SRS, the goal is to have that be a function that can be done at the customer's site. But for right now, it's kind of a back and forth because our simulation software is still being ironed out. As far as, are there certain parameter sets that are applicable to SRS? I would say yes. So once we run a part through SRS, we are, like I said, going to be slightly modifying both the scan strategy and the length of the trajectories throughout the part. And so we might have to slightly optimize the parameter set for those specific applications. But as far as, do we have SRS available on many of our materials? Yes. As far as, will we need to slightly modify your parameters to achieve that increase in part quality without supports, it probably will take some slight modification.
Great, thank you, Ty. At this point, does anybody else have any additional questions? If not, we'll go ahead and wrap. We'll give a few more minutes. So going back to the SRS type, it sounds like very much a collaboration between the customer and our R&D department to figure out the best scan strategy and parameter for each case. Is that right?
Yes, that's correct.
Very cool.
Yeah, I think highlighting the SRS technology is going to be really key. If you're looking to do something like, for example, the bike yokes that I showed in our applications page, that'd be a great application for utilizing SRS, where eliminating just the few supports that are on the part. But since you're doing batch production of these parts, you're running the same parts over and over and over again. And instead of having to pay the setup and machining costs of having every one of these parts sent to either an in-house or an out-house CNC vendor, you can simply eliminate those supports and save that post-processing time, save the EDM time, I think it's a huge win for anyone doing, you know, part production to a larger scale. SRS at this point, you know, for a one-of-one run, sometimes because, you know, of the development process, it might be quicker to just run that initial build on traditional supports, but it's really about optimizing the production quality parts and, you know, really saving your time spread across many parts, you know, over the duration of the lifespan of that part.
Very cool. Thank you, Ty. So we have someone raising their hand. So I'm going to go ahead and allow them to ask their questions. Go ahead, Oliver. I think you are muted, Oliver.
So yeah, Ty, could you please explain to us, like, if we have one machine and now I want to scale up to like multiple, what should I prepare for now when I plan my facility?
Okay, great question. So let me hop back to our technical data sheet. So as you can see, we highlight our external dimensions and our power requirements for the facility. And those are two things I would not take lightly. So when you're planning out your facility, first of all, make sure you have the room to properly install all of your machines with egress paths, offsets from walls for proper electrical safety requirements. And then also make sure you have enough incoming power to the facility to actually power all of your machines at one time. That sounds like kind of a given, but you know, as we install machines all over, you'd be surprised how often we run into, you know, not being able to fit in the facility or not having the power on hand. As far as making sure you have, you know, the basics, then I would start to look at expanding your powder handling and your argon supply and your sieve throughput. So when you buy your first 350, I'd highly recommend purchasing a whole package where you get your powder unit, several of your powder containers, and a sieve. But then as you grow in size, you may be able to have some of those components, such as your sieve cartridges and your sieve itself, be floating, and you might only need one of those machines for one of those units for every 3 machines. So I would say, you know, get in touch with our applications team, and we'll be happy to lay out kind of a growth path for you in the long term, where we can say, you know, I would recommend buying your first machines with 1 sieve, probably 9 powder cartridges and 3 powder supply units. And then as you grow with that, you know, we can say, then at this point, I would get my second sieve and expand from there.
Great. Thank you, Ty.
Thank you.
And thank you for the question, Oliver. Does anyone else have any additional questions? And again, we will be attending IMTS in Chicago next week. If you are in the area, please stop by the booth. And we'd love to talk to you regarding any of the questions you may have on our extensive library of offerings. And we will be at booth 433144. Great. All right.
Yep, 433-144.
Right. Thank you. So if there's no additional any questions, thank you again, Ty, for the awesome presentation. And thank you everyone for taking your time to be here on Tuesday. And we'll see you next time. Bye for now.
Yeah, thank you, everybody.